This is in the form of 2 sin theta cos theta, which can be written as sin 2 theta. A 1 by 2 cos inverse t, we have taken it as y here. What is A 1 by 2 sin inverse t? It is x. So when you differentiate this with respect to x, this implies dy by dx is equal to du by dx minus dv by dx here. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am, Vidhyaashram School of Excellence, Mysuru. So last session we have taken problems which you can expect for 3-mark question. In this session we'll be continuing the same 3 marks question from the chapter Continuity and Differentiability. So let us move on to the first question. Find the derivative of log x to the power log x with respect to x. So we have log x both in the base and exponential form. So let me take here y is equal to log x to the power log x. So whenever two functions are in exponential form, let us apply log on both sides. So here we get log y is equal to, this can be written as log x into log of log x. Now differentiate with respect to x on both sides. Log y can be written as 1 by y into dy by dx. And here we have two functions. So let us apply the product rule. So the first function into derivative of the second. That is log x into derivative of log x is 1 over log x into again differentiating log x is 1 by x. So here next we have plus second function, that is log of log x, and derivative of the first function, that is log x, which becomes 1 by x. So now let us write here. So dy by dx is equal to, so let me shift y here. So y into log x cancels here. So we get here 1 by x. And there we will get 1 by x log of log x. So replace back the value of y. So what is y? Log x to the power x. And in both the terms, you have 1 by x as a common factor. So if you take 1 by x as a common factor, it comes to the denominator here. And here it becomes 1 plus log of log x. Thus, this is the derivative of the given log x to the power log x function. Next one, find dy by dx if y is equal to cos x cube into sine square x to the power 5. So clearly here we have the two functions in the form of a product. So let us apply the product rule. So y is nothing but dy by dx. So the first function is cos x cube and the second function is sine square x to the power 5. So we have first function into derivative of the second. So when you have sine square, just write it as 2 sine x to the power 5. Now differentiate sine. What is the derivative of sine? It is cos x to the power 5 plus second function, that is sine square x to the power 5 into derivative of the first, that is cos x cube. What is derivative of cos x cube? It is sine x cube, but we have x cube inside sine function. So that is why we have to derive x cube again, which becomes 3x square. Now clearly you can see here dy by dx is equal to cos x cube. This is in the form of 2 sin theta cos theta, which can be written as sin 2 theta. So that is why this can be written as sin 2 into x to the power 5 plus sin square x to the power 5, and here we have 3x square into 3x square sine x cube. So thus this is the derivative of the given function. Next we have, if x is equal to square root of a sine inverse t plus y is equal to square root of a cos inverse t, then prove that dy by dx is equal to minus y by x. So first let me convert x is equal to a and half can be written as to the power. So this can be written as half sine inverse t. So when you have the root a power m, it can be written as a to the power m by 2. So that is half into m. So that is why here half into sine inverse t can be taken. And similarly we can write here y is equal to a half cos inverse t. Now what is the derivative of a power x? It is a power x into log a. So whenever y is a power x, dy by dx of a power x is a power x into log a. So that is why here I am differentiating with respect to t, because this is clearly parametric function. Both x and y are expressed in terms of t. That is why you have to derive the equations with respect to t. Now dx by dt is, if you take this as a power x, then it can be written as a power x into log a. But x is not just simply x here, it is half sine inverse t. So that is why you have to derive it again. That is d by dt of half sine inverse t. Since half is a constant, we can take it out. So we get here dx by dt is equal to a half sine inverse t log a into 1 by 2. What is derivative of sine inverse t? It is 1 divided by root of 1 minus t square. Now thus here similarly, if you find dy by dt, clearly you can write this as a half cos inverse t into log a into half, and derivative of cos inverse t is minus 1 divided by root of 1 minus t square. Now here I need to show that dy by dx is equal to minus y by x. Let's see here what is dy by dx. Dy by dx here is dy by dt over dx by dt. So what is dy by dt here? A half cos inverse t into log a into 1 by 2 into minus 1 by root of 1 minus t square whole divided by a 1 by 2 sine inverse t into log a into 1 by 2 into 1 by root of 1 minus t square. So clearly you can see log a 1 by 2 1 by 2 root of 1 minus t square root of 1 minus t square get cancels. So I am left with here negative sign in the numerator. So minus a 1 by 2 cos inverse t divided by a 1 by 2 sine inverse t. So what is a 1 by 2 cos inverse t? We have taken it as y here. What is a 1 by 2 sine inverse t? It is x. So replace it there. So therefore dy by dx is equal to minus y divided by x. Hence we prove. Next one, find the derivative of x to the power x minus 2 to the power sin x with respect to x. So here we have two functions, both are in terms of exponential function. So here let me take let u is equal to x power x and v is equal to 2 to the power sin x. So now let me differentiate both with respect to x here. So therefore, here let me apply log u. Then it becomes x log x. So let us derive it. 1 by u into du by dx. Let us apply the product rule. First function, derivative of log x is 1 by x, plus second function, derivative of first is 1. X get cancels. So I get here du by dx is equal to, shift u here, u into 1 plus log x. What is u actually? X power x. So therefore, du by dx is equal to x power x into 1 plus log x. Next we have v is equal to 2 to the power sin x. So v is equal to 2 to the power sin x. So apply log on both sides, then it is log v is equal to sin x into log 2. So again let us differentiate it, then it becomes 1 by v dv by dx is equal to, first function is sin x, second function is log 2. So derivative of log 2 becomes 0 since it is constant. Plus second function is log 2. Derivative of sin x becomes cos x. So now here we have dv by dx is equal to v into log 2 cos x. But what is v? It is 2 to the power sin x. So therefore, dv by dx is equal to log 2 to the power sin x into cos x. Now, from the case we have taken x power x as u, v as 2 power sin x. So that is why we can write y is equal to u minus v. So when you differentiate this with respect to x, this implies dy by dx is equal to du by dx minus dv by dx here. So now we have got both du by dx and dv by dx. So therefore, dy by dx is here x to the power x 1 plus log x minus log 2 into 2 to the power sin x into cos x. This is the derivative. So whenever two functions are given in the form of an algebra, that is u plus v or u minus v form, then take y is equal to u plus v or u minus v, differentiate separately with respect to x, find du by dx, find dv by dx, then substitute it, which will be the derivative of the given function. Next question. If x is equal to a into theta plus sin theta and y is equal to a into 1 minus cos theta, prove that dy by dx is equal to tan theta by 2. So here it's a parametric function. So let us derive with respect to theta. So now here I'll take dx by d theta. So a is constant. When you differentiate theta with respect to theta, it is 1. And when you differentiate sin theta, it is cos theta. And here we take dy by d theta is equal to a, derivative of 1 becomes 0, minus cos theta is minus sin theta. So therefore it becomes sin theta, which becomes a sin theta. Now let us substitute it in dy by dx. So dy by dx can be written as dy by d theta divided by dx by d theta. dy by d theta is a sin theta and here we have a 1 plus cos theta. Now here a get cancels here. So here we have sin theta, which can be written in the form of a multiple angle formula, that is 2 sin theta by 2 cos theta by 2. And 1 plus cos theta can be written as 2 cos square theta by 2. So now we have 2 which will get cancelled. cos theta by 2 and 1 cos theta by 2 get cancels. We are left with sin theta by 2 cos theta by 2. What is sin theta by cos theta? Which is nothing but tan theta, and hence here it becomes tan theta by 2. So therefore dy by dx is equal to tan theta divided by 2. Next we have, if x is equal to a cos cube theta plus y is equal to a sin cube theta, prove that dy by dx is equal to minus cube root of y by x. So here we have x is equal to a cos cube theta. So derive it with respect to theta. Dx by d theta is equal to a is constant. Cos cube theta can be written as 3 cos square theta, and cos theta can be written as minus sin theta, which is the derivative of cos theta. So therefore dx by d theta can be written as 3a sin theta cos square theta. So minus outside. Next we have y is equal to a sin cube theta. So therefore dy by d theta is a into sin cube is 3 sin square theta, and derivative of sin theta is cos theta. So therefore dy by d theta becomes 3a sin square theta into cos theta. Now I need dy by dx. So therefore dy by dx is nothing but dy by d theta over dx by d theta. So dy by d theta is 3a sin square theta cos theta, and dx by d theta is minus 3a sin theta cos square theta. So cancels. So we are left with minus sin theta divided by cos theta. So now I need dy by dx in the form of y by x. Look here, we have x is equal to a cos cube theta. So what is cos theta here? Let's see what happens now. So x is equal to a cos cube theta means, if you shift a here, it is x by a is equal to cos cube theta. Now take cube root on both sides, then it becomes cube root of x by a is equal to cos theta. Similarly, we have y is equal to a sin cube theta. So therefore y by a is equal to sin cube theta. This implies cube root of y by a is equal to sin theta. So in the place of sin theta and cos theta, replace this value. So this implies dy by dx is equal to cube root of y by a divided by cube root of x by a. So we have minus, thus we have minus cube root of y divided by a over x by a get cancels. So therefore dy by dx can be written as minus cube root of y divided by x. Hence the equation is proved. Next is differentiate tan inverse of sin x divided by 1 plus cos x with respect to x. So here we have y is equal to tan inverse of sin x divided by 1 plus cos x. So the function is starting with an inverse trigonometric function. So let us simplify this first. So I can write this tan inverse of sin x and 1 plus cos x. Here I'll use the multiple angle formula. Sin x can be written as 2 sin x by 2 cos x by 2 whole divided by 1 plus cos x here. So can be written as 2 cos square x by 2. So here cos x by 2 cancels. 2 get cancels. We have sin by cos. So therefore y is equal to tan inverse of sin by cos is tan x by 2. Now tan inverse of tan, when you have this, is clearly y is equal to x by 2. Now let us derive it because it is simplified. So we have y is equal to x by 2. Derivative of y is dy by dx. And derivative of x is 1. So x by 2 becomes 1 by 2. So This is the answer. Next question we have here. If y is equal to cos inverse x, find d square y by dx square in terms of y alone. So, in terms of y alone means completely you have to express d square y by dx square in terms of y terms only. So, now here we have y is equal to cos inverse x. So, this implies x is equal to cos y. So, we have x is equal to cos y here. Now, let us differentiate with respect to x. So, differentiation of x is 1. Differentiation of cos y is minus sin y into dy by dx. So, therefore, dy by dx here becomes minus 1 by sin y or minus cosecant y. Now, let us differentiate it again. So, when you differentiate dy by dx, it becomes d square y by dx square. Minus we have. What is derivative of cosecant y? So, the derivative of cosecant x is minus cosecant x cot x. Similarly, for cosecant y, it is minus cosecant y cot y. Since you are differentiating y, you have to write dy by dx. What is dy by dx? We got dy by dx as minus cosecant y. So, let us substitute here. We get d square y by dx square is equal to, here we have both minus, which becomes cosecant y into cot y, and dy by dx is minus cosecant y. So, therefore, d square y by dx square becomes minus cosecant square y into cot y. So, this is the answer. That is completely the second order derivative is expressed in terms of y alone. So, this is all about the 3 marks types of question in this chapter. We'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.